reviewing where we left off. So, what are the properties, what are the pieces of information we need to make a firewall rule? What were they? They're even on the screen. Yeah, it's no big mystery. So what are those pieces?
Source IP.
You need the source IP address, which is going to tell you what?
Where it came from.
Where the traffic originated from. What's our next piece?
Source port.
Source port. What's the other word for a source port? Or what's the word that lumps them all together? Starts with an E. Ephemeral, yeah. So source ports are ephemeral ports. What do we usually have for source ports? Like, what's the point of an ephemeral port? Think about in your Wayback Machine all the way to Tuesday. What's the point of a source port? No one knows what a source port does? You guess not? What was the purpose behind the source port? Why do computers have source ports? What is the reason why we have these?
You do more than one thing on your computer.
You do more than one thing on your computer. So when your computer receives a packet, it needs to use the source port in order to figure out what?
Program.
There we go. What binary or what process running on the computer do we need to hand the data of that packet back to? That's what source ports are there for. So, for us as a firewall perspective, can we figure out what a source port is? What the source port will be?
It should be contained in the packet.
Well, yeah. Can we predict it when we're making a firewall rule? Do we know, like, can we figure out a destination port? Do we know what that would be if we're making a firewall rule? Yeah. Because typically it's going to be like, oh, I'm running a web server. My destination port should be, drumroll, 80. Yeah. What will my source port be? You have no idea what your source port will be. Because who picks the source port? Whatever the operating system is running on the computer, right? So is there consistency among the ephemeral ports? No. There's a standard out there, and who follows it? Like absolutely no one, yeah. So those are our source ports. Destination IP is where we're going, destination port. What's one other thing that's usually going to be inside of our firewall rules? That we'd maybe have somewhere right in here.
Like the type of packet, TCP, UDP.
Yeah. So you'd have like protocol in there or something like that if it's TCP or UDP. So that is the basics of making our firewall rule stuff. So the next really, really important piece of this is that at the end or at the bottom when we make our lists of firewall rules, it is assumed at the bottom on most firewalls that this rule exists. So what is this rule going to do?
Block all traffic, not specified.
Yeah. So when we're making firewall rules, if you think about back to your days when you were writing if statements, and you'd write if, and then you'd have if else, or else if, or whatever language you're using, right? You'd have all these ifs and then additional else conditions. Which one would become true? Like, let's say when you look at it, there's multiple things that could become true when you're writing if statements. The first one will be true. Why won't any of the other ones ever be looked at when you're making if statements?
Then it skips to the end.
Yeah, because then we just jump over it, right? So if we did something like to review our programming days, actually let's come over here. So if I have like, I don't know, variable equals 5 if var equals 6, well that's not going to do, stuff. Else if var equals 5, other stuff. Else if var equals 6 minus 1, would this also be true? But in the event that we've hit, this particular else statement, we're just going to skip over it. We're going to do other stuff, whatever this says, and then we're just going to jump all the way down here and skip through the rest of it. Firewall rules are the same thing. So when we're making these, we have to pay attention to the order of operations, because the moment we end up with one of these rules becoming true, we stop evaluating altogether. So when you ask me the question then, like, why aren't my firewall rules doing what I said? I'm like, they're doing exactly what you said to do. You just have them in the wrong order. So at the bottom, there's always a block all inside of there. It's assumed. Usually I like to put that in there manually anyway. So the idea behind the block all the stars, it's going to always be true. We hope that, some rule caught it ahead of time. But in the event that a rule didn't catch it, there's a block all down at the bottom. The reason why a lot of times I will explicitly put a block all rule of my own, even manually, because there's like that. Basically, my firewall syntax or rules are going to look like this, which seems really silly. This is the one that the firewall makes in there automatically. A lot of times for logging, firewalls will not log that. If you hit the implied block all rule, it just erases the packet and doesn't say anything about it. So there's pros and cons to that, right? So the pro to that is you're probably going to have a lot of stuff hit this and, just get into Never Never Land, and you don't really care because there's a lot of junk on the internet always hitting your firewall. The con to that is if you're troubleshooting something and haven't realized that your rules aren't hitting correctly, like you have a mistake in a firewall rule, and you're looking for an event in your event log and you're never going to find it, you need to put that in there explicitly and tell your firewall to log it. Most, like pfSense, for example, this is not the case. pfSense always logs with its implicit deny rule, I think. But basically every other firewall does not. So there's that. So next one, what's UDP 53 to 8.8.8 going to do for us if we're going to make that firewall rule?
DNS to Google.
We're going to allow DNS out to Google. And then we don't want to we only want to use Google's DNS. So if we go through and make these two firewall rules, what is this going to do?
It's going to block all DNS, isn't it?
Yeah. So my condition here, what I would tell you is, I want you to only allow us to go to Google's DNS. And if you make this set of firewall rules, then what we've effectively done is this is going to block all DNS. Is this second rule ever going to get evaluated? No, because this one's going to be true first. So that's why we have to pay very, very close attention to how we're doing this. Basically, the way we would say this is we kind of come up with the specificity of firewall rules. Like this rule is, or like this condition is more specific than this really generic one. So generally speaking, you put the more specific rule first, because this rule is has more parameters, is more specific, whereas this one is more broad going on. Make sense? So, I forgot what other slides I have in here. Yeah. So what we will attempt to do here, actually let's flip over here, is see if we can fire up our virtual machines now. Say, hopefully we'll have moved around by now for us. We'll give it a hearty 15 minutes. What we have, and what would we say? When we go to start these up, I have done something that's actually probably going to cause us a little bit of problem, but that's actually okay. So what we have going on in here is a series of virtual machines. We're simulating an internet network. So the internet network is right here. And what I have in the middle is, it says Minneapolis core. So this actually comes from a bigger group of virtual machines where we have Minneapolis and Chicago. But for us to get started, I just deleted all the Chicago ones. Though one thing I did that will cause us a little bit of irritation for getting started is I did a full upgrade on this to the newest version of pfSense. So it wiped out all my little helper things beforehand. But that's okay. So what we initially are actually going to do is play around with just setting up a blank pfSense from scratch. In the past, I have gone through and set up pfSense ahead of time so that we didn't have to worry about configuring interfaces and whatnot. But I have gone on my soapbox and changed my mind of how I'm going to do that this year. Any idea why? In your job, are you ever going to buy a new firewall and someone's just going to happily configure it a little bit for you when it gets there for you? It's probably going to be awfully blank looking when it gets to you. So that's what we're going to be dealing with here. So we'll see if those guys are starting up, which is going to why I usually start these ahead of time. Other fun things for us to talk about. So when we're sitting here specifying a source IP address, do we have to use one explicit IP address? Source or destination, any of these? No. What else could we put inside of here instead of like just like 192.168.10.20 or 30, I guess, since I made a typo. What could we put instead of that? Like, let's say we want to let one entire network in. So what we would actually do, if we wanted to let all of the 192.168.10s through, is just use subnetting again. Generally speaking, all firewalls are going to respect this in some form or another. To that case, when we're talking about source IP, like if we're allowing the internet to access one of our web servers, a lot of times some firewalls still will have us do star for the source IP address. And I think we talked about this last time to where that is the IP address we would use. So when we subnet this out, what does this address represent? It is the subnetting equivalent of, drumroll what? Everything, yeah. When we like do the subnet math here, we are including every single IP address in this entire block. So that will be how that works. This looks like this is going to take a while for us to start up. So the next kind of rule of thumb for us is when we go into our firewall, we have to configure all sorts of rules, and we have to know who is originating the traffic and where is the traffic going to. The next piece that's going to be really, really important, it's going to add to the complexity, is compared to traditional old school firewalls, now when you define firewall rules, you're defining it generally by interface. Whereas before, there'd just be this broad list of rules that you'd create for all the IP traffic moving back and forth. Now, when we create IP rules, we actually specify on the WAN interface. It has its own stack of firewall rules. The LAN interface has its own stack of firewall rules. What's the WAN interface going to do? Why do we call it WAN versus LAN? Before I start using random terms and someone looks at me. Because I make assumptions that everyone knows what these mean. So WAN means wide area network, which is a really fancy way of saying what? The internet. Whereas LAN is local area network. This is actually a silly term to use as well. Because are firewalls nowadays generally just going to have two interfaces on them? A WAN and a LAN? No. So we generally are going to end up with a WAN, a LAN, DMZ. There will be like management interfaces and stuff like that. Like, this is where all the switch and router admin interfaces live on. All of our subnets are basically going to be different interfaces on a firewall. When we go a step further with all of this, I might just have overcooked our expectations for today, and these just aren't going to start up for me, which is fine, I guess. So the new problem we have is in this new style of doing firewall rules, guess how many interfaces we generally end up with if we're subnetting everything to death like this? Or let's take DSU, for example. Anyone have a guess at how many subnets DSU has? Caden, do you know?
Not entirely, I guess, if there's one for each building, pretty much.
There's one for each building. There's actually more than one for each building, actually. So there's at least 2 per building, whether they're active or not. I'm not sure on that. There's wireless networks or server networks. I would say overall for DSU, there's probably around 35 total subnets, give or take. Probably even more than that. So when you log into DSU's firewall, do you suppose we have 35 different tabs for 35 different sets of firewall rules? No. So that is going to be one of our pfSense limitations, and what I'm doing is foreshadowing what will be. So if DSU used pfSense, we would log in and we would have 35 different tabs, which is again a pfSense limitation. What newer firewalls all do is create zones, security zones. So we can probably, for example, lump together at DSU some security assumptions. We can assume that the guest network, what level of access or privilege do we want them to have for accessing things inside? Nothing, right? What level of access or privilege does DSU want to put on our WAN interface? Do we want the WAN interface to be able to access things inside of the network? No. Do we want the guest interface to be able to access things inside of the network? No. So what we actually do then is we make security zones. So what security zones let us do is make assumptions, essentially. So instead of saying, well, here's the guest subnet, here's the WAN subnet, which is a large one, not literally, but we're assuming all IP addresses of the world live on there, we would actually take guest and WAN, put both of those interfaces inside of a security zone, and make all of our firewall rules based on that. So if we make a firewall rule, guess it, firewall rule saying the internet is allowed to browse our web server, which is probably safe to say, well, so can the guest network, right? But beyond that, we don't give any additional access to stuff. Similar things exist with like student Wi-Fi network and dorm wired network and gaming network, stuff like that. We can probably assume similar access restrictions are going to exist on all of these different subnets, so they could be lumped into like a student's zone. So rather than having 30 different subnets that we actually have to manage firewall rules for, we can start to lump them together because we know access levels are going to exist. So if we go back to a business where we have the accounting department and the marketing department and all those places, can we assume that there's some really similar access controls for each of those groups? Like they can get to the file server, they can get to the, the internal SharePoint site, stuff like that. So we can lump all those together and say, here's the zone that contains all of the user workstations. Then we can actually use the IP subnetting to actually specify, well, like the accounting department can also get to the accounting server, but the marketing department can't. So zones will come up and eventually be our friend.
Oh, it's running.
It's running now. So, let me look over here. This is the one extra interface that I get that you guys don't have, is I have the host tab, so I can see which physical server they're running on. So, like when I first tried to start these, they were all running on ESX45. and we notice CSX45 must have become upset and full of things because it moved stuff around, which is why I start our virtual machines up before class usually, but sometimes things don't go like I like them to. So when we go to start to configure this, what most firewalls are generally going to do is start up, and then there's going to be a little insert that comes in the firewall rule that's like, hey, plug into port 0 on the firewall with your computer, configure it for DHCP. So probably what that firewall is going to do is boot up, send out a DHCP address, and just go to whatever the default gateway it hands you, and it's going to load up its web interface and stuff like that. So generally speaking, most folks out there are probably going to receive a firewall or two, and it's pretty simple for you to go manually configure it. If you want to get really cool with it, with most firewalls or just network appliances now, you can actually PXE boot them. So like if you receive a shipment of 1,000 switches that you need to configure, going along with your serial cable and configuring them one at a time is going to be rather unpleasant. So instead, you can actually set up PXE boot or even just DHCP options that just tell your switch to go TFTP to this particular server and grab your default configuration from there. That way you don't have to go do it. So then what you do is just sit there, plug them all in, plug in a network cable, turn them on, and wait for them to just show up inside of a management interface for you. We're not going to do anything quite that cool, at least right now. So what I'm going for here is we've gone through and gotten our base console up. Generally speaking, most firewall rules, if you say plug in the serial cable to them, which is what we're pretending we're doing here, is plugging in a serial cable. With a case of pfSense, you can actually install this on a computer that doesn't have a display or like a VGA port, and it will actually use the serial port as its display. So you don't obviously plug a monitor in, you'd plug in a serial cable and open up PuTTY or TerraTerm or something, and you'll actually get this exact same GUI on it. So that is different than most firewalls where you'll boot them up, plug into their serial port, and you just have a straight up command line interface. There's very, very little that we're actually going to do from here. A case in point of please don't get confused when I tell you to go make firewall rules on pfSense. That is not done from here. That is only done through a web interface. The closest you could get to configuring firewall rules from here is going to the command line shell, and pfSense stores all of its config in a big XML file, and you could go like manually edit XML with VI, which would be a treat. So we don't want to do that. But what we can do here is assign IP addresses and stuff. So we've got that going for us. And now I've actually forgotten, I believe, 6443, 242, I think is what we need. Yeah. Okay. So what we're going to do is we're not going to use the IP address 192.168.1.1. We want to configure this firewall to use all public IP addresses because for right now, when we first get like our firewall training wheels going on, we're not going to do NAT because NAT throws all sorts of complexity at us. So we're just not going to worry about that. So we need to come in here and enter a 2. So 2 is going to let us set IP addresses on the firewall interfaces. Right now, it says LAN, which is interface EM1, is static. Why is it EM1 and not ETH0 or ETH1? Any guesses as to why? No. Just BSD, yeah. So BSD doesn't do the ETH1, ETH0, or ETH1, ETH0, however you want to pronounce it. It does EM1, EM0, and I, actually, to be perfectly honest, don't know what EM stands for off the top of my head, but yeah. So we want to reconfigure the LAN interface, and we're going to go 64.43.242.1. That will be our IP block. And then it wants to know, hey, what's our subnet bit count? So what would our subnet bit count be for like a slant 24 network?
3 sets of 255.
Be 3 sets of 255, so how many bits would that be? Guessing Josh knows the answer. Yeah. What's that? Enter the new sub. Oh, it does actually, yeah. I was just seeing if someone would be slipped up by the fact that it's asking you for a subnet bit count. And then I said, what would you put for a slant 24? Which would be, see, I'm messing with you. So, we're not configuring that interface to be a router, so we hit enter again. We're also not going to worry about IP6 addresses right now, so we'll hit enter again. Should we turn the DHCP server on? Sure. What's DHCP going to do for us on our LAN interface? It's going to hand out IP addresses, yep. So I'll say sure. Enter the start of the range, 64.43.242. Yeah, start at 100. And let's end at 64.43.242.150, which is quite a range because there's only one machine running on there, but it's a happy range of IP addresses. And sure, let's turn on HTTP. So pfSense kicks up here and says, okay, this is basically now going to be like your card that comes with your firewall. It says, okay, plug into the interface. You're going to get a DHCP address. Go to whatever I hand you as the default gateway, and you're going to get the admin interface. So we'll hit enter. There we go. So our next stop on our little adventure is to open up the MSP admin machine. So the admin machine is connected to the LAN network. It's connected to the second interface on here, which is NIC 1. That's our next life lesson for everyone. What number do computers start counting at? 0. So I have been the one that looked like a fool, and I've gotten to make fun of someone before too. When I've told someone, go plug this into the third interface, which is a stupid way to say something. Because when I tell you to plug something into the third interface of that firewall, what could that mean?
Number 2.
It could mean interface 2, or it could mean I counted first port, second port, third port. Those can be different things. Or, well, shouldn't be different things, but could be confusing to people. So in the case of this firewall, when we talk about the interface 1, that's really the second interface on here. It makes for a good time for making fun of people when they mess that up, though, because you go over and be like, you're off by 1. Why did you plug it into that? And then they're like, because you told me to. And that's basically how all that goes down. So we get into our admin machine here, and this is running good old Windows 7. The new version of pfSense, its interface does not play well, I guess, with Internet Explorer. So, not that that's probably going to crush anyone's day of oh no, I can't use Internet Explorer. I don't figure that's going to be a deal breaker. Oh no, I configured this IP address wrong. Or I led us astray. Either way. So Firefox is trying to go to a default home page. I had us just go configure the wrong IP address on there. I actually am going to make sure I didn't double it up. Otherwise, we'll roll with it. 64.3.150. Okay, yeah, we're fine. So, I want to get to the admin interface on this firewall. What IP address do I need to go to? Or how could I figure that out? We could check our IP address on this computer. So we open up, whoops, ipconfig. Ooh, what problem do we have? Based on what I just configured, should my IP address be this?
No.
No, why not?
DHCP
Because we configured something different, yeah. So the goofiness is, this was what was already configured on pfSense, and then we went and changed it. But no one told Windows. So how do we tell Windows to check again for an IP address? We'll release, and then ipconfig renew. And give it a drum roll. That looks a little bit better. So, now, what IP address should I go to access the firewall's admin interface?
The default gateway.
Yeah, go to the default gateway, 64.43.242.1. So 64.43.242.1. And we get the login page. So when we get to this stage, the username is admin, and the password is pfSense. Guess why it's not password one bang?
You didn't set it up as the default.
Because that is the default pfSense. Like pfSense ships with that password by default. So that's my rules of the IE lab. If it doesn't come with a default password and I have to provide one, it's password one bang. If it's something like Kali that ships with root and tor, then I leave it alone. So we'll log in, and we get the wizard to set it up. Wizards are lame. We're not going to do this. If you go through your life and depend on wizards the whole time, then you're, I don't know, the script kiddie of setting up firewalls or something. Something drastic like that. So, this is our basic homepage for pfSense. Tells us lots of exciting information. What processor it's detected, how long it's been running, DNS servers, CPU, all this great stuff. So, generally speaking, on your firewall, you don't want, obviously, like any of these things to be spiking up. Typically, so for like buying and sizing a firewall, if it's just going to do basic old school firewalling, your CPU is probably not going to do much. So that's a FYI. However, do firewalls nowadays, do we just use them to just look at IP and ports anymore? No, we actually use them for tons of other stuff. So one of them is running VPN tunnels. So that's really, it's actually a handy thing to put at your firewall, because your firewall is going to be able to appropriately give the VPN access to stuff. There's a lot of crypto going on inside of that. So as soon as we hear the words a lot of crypto, we could basically default and say, okay, that's going to use a lot of processor. The rest of these little nuggets we will actually end up coming upon later on, like state tables and stuff like that. The one thing I do want to talk about, though, is just like pfSense in general, just for those that have not used it before. So you can just go out to the website, here we go, which is now much more like trying to get you to buy their service thing, but you can just go out and download this. And if you have an old computer at home, it will just run on it. And it's actually quite good for stuff like that. So you pick 32, 64-bit, and then you pick if you want how you want it to run. So if you do the CD ISO installer, which is actually what I did, it just installs to your hard drive like a normal operating system. You can also bring down if you want to go actually for like no power usage inside of your like home router thing that you're building out of an old computer, you can actually run it off a USB stick, which will use significantly less power than a hard drive will. So run it that way, or you can actually go all the way down to where you actually have an embedded, like very, very tiny system. So this runs on basically like any modern-ish x86 computer. So that's what's kind of cool about it. You can also go buy little pfSense appliances if for some reason you don't want to. And it's actually kind of cool because they have like a neat little guy. Yeah, there we go. Let's look at security appliances. By the way, that's another marketing term. We don't call them firewalls anymore. They're security appliances. That's a new thing. But when I'm talking about, like, you can get tiny little, like, low-powered pfSense boxes, this is basically, it's not a Raspberry Pi because it has 2 network interfaces, but this is basically the Raspberry Pi equivalent of a firewall. But $150 seems actually super expensive for this, but either way. So pfSense can run on very, very tiny little computer. And it actually runs really, really well. You're probably not going to push like gigabits of traffic through this, but yeah. So, anywho, when we are poking around in here, there are lots of system settings and whatnot. We'll eventually start to look at some of those. The one I want us to go to right now is go to interfaces and then assign. So pfSense, when you install it, no matter what you install it on, if you install it on a computer with 2 network interfaces, or if you install it on a computer with 50 network interfaces on it, it's just going to load a WAN and a LAN. That's all it's going to come pre-configured with. Our computer has, I don't know, 3, 4 network interfaces in it. So when you go down to assign, it basically is going to show you, like, here's the MAC address, and here are the other interfaces I've detected. So we actually have, I forget, I think 2 interfaces, or 3 interfaces here. Yeah, we have 3 separate networks. We have a DMZ, a LAN, and a WAN. So for us going forward here, we want to add the EM2 interface, and then the kind of annoying thing that pfSense now does is instead of calling them anything, they're optional interfaces is what it's doing. So when we come up here to interfaces now, we can see our opt1. So we'll go look at that guy. We have to enable the interface and then give it a name. I'll call it DMZ. And we want it to be configured with a static IP address. We're not going to worry about IP6. We can try to spoof MAC addresses. Why would we spoof MAC addresses on a firewall? Any guesses of some situations that we might have? No guesses? Yeah, so you can basically have like a, say you are swapping out your home router at home, your home router, and you want to get the same IP address back because you have something going on. So you could clone the WAN interface MAC address of your home router. Then your ISP will probably hand you the same IP address back again. So that's one reason why you would do that. There are some ISPs that are silly and have this like, we're going to secure our network by doing sticky MACs. What are sticky MAC addresses? It's a great way to secure wired networks. It's really dumb.
Like only that MAC address can connect to that port on the switch.
Mm-hmm. So like basically the ISP, or in the case of configuring sticky MACs on a switch, the first computer to connect to it is the only computer allowed to connect to it, which is dumb, in my opinion. Maybe there's a reason for it. ISPs will sometimes do that, or they'll require you to register your MAC address, and if you don't feel like calling them and switching your MAC address, because for some reason your ISP is like, we're securing our network because we use MAC address filtering, you can just be like, well, no, I'm just going to clone it. The other one is ARP. What's ARP?
Basically the opposite DNS.
Yeah, it's sort of like DNS at a lower layer, right? Whereas DNS is like bridging layers 3 and above, kind of. ARP is bridging layers 2 and 3. So ARP is the association of a MAC address to what?
IP.
To an IP address, yeah. So, and this actually happens not so much in home networks, but when you go and have like a real internet provider at your business sort of thing, they will have, we'll take SDN for example. SDN has like some sort of a core router thing because they're a major kind of backhaul provider. So they have some equipment that's hardy sitting here in Madison. I think actually it's over by East River Electric. I think they're actually like bolted onto the back of their server room. So when you are a business here in town and you have SDN fiber ran to you, you plug in, their router talks to your router and life is good and everyone's smiling. What SDN will then do is have an ARP table on their router that says, okay, I know when I am connecting to DSU's connection, I know that this is the MAC address I need to talk to for this IP address, which is normal. Like when you and your ISP are talking to each other, you're using a layer 2 connection, even though it's not a switch that's probably inside of there, but you're still having a layer 2 conversation, and the router just knows this is the MAC address I have to send stuff to in order to get to this IP address, and the wonders of networking go on and on from there. If you go upgrade your firewall, what can happen? Because generally speaking, if you're SDN communications, the ARP table isn't exactly just going crazy with updates, right? SDN isn't adding and removing customers in this area much. Like a new business comes in, new customer kind of thing. That's about it. Whereas home MAC addresses, like if you're mid-continent providing home internet, MAC addresses probably change a little bit every day. Not a ton, but there's, I don't know, what would the statistic be? Like there's one router upgraded in Madison every day or something like that. Every day a kitten is saved. So what will happen is when you go upgrade your firewall, if you're a business and whatnot, plug in the new firewall, have all of your rules and configuration perfect on your firewall, try to go to your website or whatever, and it doesn't come up. Never comes up. And you're sitting here going, what's going on? So then you start running Wireshark, and you actually will see your ISP is trying to talk to your old MAC address because it hasn't bothered to update the ARP table for some reason or another. So how would you fix that?
Either spoof or
You could spoof it. That's one way, and that's like an instant fix. What's the other way? Wait. So there's 3 ways you fix it. You could wait, and eventually someone's going to send out and recognize an ARP update from you.
Or you could just call them and ask them to.
Or you can just call them and say, like, you guys need to change the TTL values on your ARP table because our network is gone because you're not updating your ARP table. So that's a thing that actually, as silly as it seems, like, and I generally speaking always ignore this particular field, but there's actually reasons for it in there. Personally, moving forward, and this is on our DMZ interface, which none of what I just talked about applies to. This only applies to the WAN interface. But personally, if you are a large business and you are going to upgrade your firewall and swap stuff out, I would not spoof a MAC address because that just leads to years later when you come into this interface. Because like once you've set the config on this interface, how many times in your life do you suppose you look at it again? Yeah, like what? Yeah, when something's broke, you're going to scroll through here. So I would not recommend doing the MAC address spoofing because someday you're going to look in there and be like, why is that? Why are we spoofing our MAC address? Or someone else is going to log into the firewall and be like, this is silly. Why are we spoofing MAC addresses on like a $10,000 firewall? We're better than this, right? If you're going to upgrade your firewall, I recommend calling your ISP and saying, oh, by the way, heads up, at this time we're going to do this thing, so that they kind of know what's going on. Anywho, long tirade on that. But that's what the MAC address spoof field is there for, is all of those reasons. Which, again, is like one of those a field that you most of the time are just going to gloss over, but there's actually a lot of reasons for them being there. Anything else super exciting? MTUs are generally not something we're going to mess with. What's the MTU? Maximum transmission unit. And what is it generally going to be?
Max size of the packet you can send.
Yeah, it's the biggest size of a Ethernet frame that we can send out on the network. Usually it's 1,500 bytes. Generally speaking, for connecting to the internet, 1,500 bytes is safe for everyone. The only reason why this should really ever change is if you're running like weird storage stuff through a firewall, and that would be weird. So that we just typically leave the same. I actually don't have no idea what MSS is. This is a new field for me. If there's an MSS clamping for TCP connection above -40. Yeah, I'm not quite sure what that's for. Then we can manually set speed and duplex kind of stuff. Generally speaking, this is also a, I would probably let your network adapter figure all of this out for you automatically. Because if it's not figuring it out automatically, you probably have other problems. So, that being said, why, can anyone dream up a reason, why would a network adapter not automatically figure out its speed and duplex? There's usually one common reason for why. And to go to the back end of this, like normally when you plug in your network adapter and you go look in the Windows properties, Windows is going to be like, this is a 1 gigabit connection, or this is a 100 meg connection, depending on the kind of switch you just plugged into. Like, Windows just figured that out somehow. Sometimes you're going to be like, this is a gigabit port. I plugged it into a gigabit port on the other end. And Windows is going to come up and say, 100 meg.
Using the wrong cable.
So, not necessarily, well, it could be wrong cable if it's really, really old, or it could just be a damaged cable. So usually if something is going wrong here, that means bad cable somewhere. Again, the like me spending time talking about things that seem really like, why would we care about that? It's crazy how often cables just die. I have been sitting in my office and I get alerts coming off the iLab for stuff, and it'll be like ESX13 interface 4 just went down. And I'm like, what? And go like do over there and like looks awfully plugged in to me. And unplug the cable, plug it back in, link light doesn't come up. I'm like, scratch my head. Go over to like box O cable in the data center, and I need one that's 3 feet long. So I get one that's about 30 to test with, because that's just, there's never the correct length you need. Plug it in, interface comes back up full speed. I'm like, have these like little moments where I question my sanity. Then the cable just goes bad. It's, I don't know, it's a feature, it's what they do. It's super annoying, but they just go bad. So, that's why speed and duplex. Usually if something's going on, yeah. Finally, we are left with the IP address to configure. We're on the DMZ interface. So, I don't remember that. It should be 64.33.152.1. 64.43.242.1, right? That's fun. There we go. And it's not super obvious, but look what we have over here. A little drop down with slashes in it. Let's put a /24 inside of there. And we will hit save. 64.43.240. Oh no, did I botch something? Oh, okay. 64.32. 152?
Yep.
So a little secret, 64.43.242 is an IP block I used to use for something. So it's really actually silly that I put that in here, because my mind just always rattles off that. It's an IP address from like 15 years ago, but typed it in so many times. The other thing, basically in pfSense and most firewalls, after you save a configuration change, you have to apply it. So really the only exception to this is Cisco devices. So pretty much every other device except for Cisco, you can go and edit configuration, whether it's in the web interface or command line or whatever, save the configuration, life is good. Then you have to say, okay, take all this config and make it live, make it active. And that's what pfSense is saying here. So we need to say, apply the changes. In Cisco world, that's not the case. In Cisco, if you're going and editing commands or editing configuration with their command line, as soon as you've had set the IP address to this and hit enter, that's live. So pros and cons to both sides of that. So what do we have for time? Oh, we still have all the time in the world. Everyone's super jazzed about how we're spending an entire day and all we're doing is setting IP addresses on a firewall, right? Everyone is sitting here being like, this is my life now? This is what we're doing? But even after I make fun of it, at some point when this is an assignment, you're going to be like, where did we have to go to get to that in the firewall interface? And then you're going to go look at this video again. And then you'll probably even annoyingly scroll to the part where I make fun of this. Yeah?
I'm having mine, I'm probably getting mine saying it's overlapping.
Oh, yep. That's because I initially typed in the totally wrong IP address. You want to do 64.43.152.1, not 242. That was a do as I say, not as I do, because I said the IP address out loud and then proceeded to type the exact wrong thing. Which, as things go along here, that's going to be a thing. Never mind what I'm doing right now. I forgot the IP address that I need to use. Next, so 102. Okay. So back in here on our WAN interface, right now the WAN interface is configured to get its IP address from DHCP, which at home would be great. We're going to switch this to static, and we're just going to turn off IP6. We keep going down, down, down. Here we are. So on our WAN interface, we want 24.220. No, I've already forgotten this. 24.220.181.102. So that's our IP address configuration stuff on our WAN interface.
Can you scroll up?
Yep. All I did up here was disable. This is on WAN interface, not DMZ. So I set this to be static, and then I just turned off IP6. So as much as I'm struggling with IP addresses now, imagine if we're playing this game with IP6. That's true. I won't configure. I won't mess it up with old IP addresses I've used in the past. Which I believe 24.220.181 I believe is state government IP blocks. So you yeah. So there's one other thing that is specific on the WAN well, this block of config exists on every interface. It's normally unchecked on all the other interfaces, but on the WAN interface it's checked by default. So what this does is hard blocks on your WAN interface all of the 10 dot IP addresses, the 172.168, and the 192.168 addresses. Why would pfSense by default block those on the WAN interface?
Because they're private addresses, they should be coming from the internet.
Yeah, so on the internet we should never see a 192.168 address talking to us on our WAN interface. Inside could totally be legit, but from the outside, like, that should never exist. That's what these other checkboxes are for, is to block IP addresses that are not yet assigned by IANA, which is probably none. Then there's also like the research networks and stuff like that are all blocked as well. Interestingly enough, it also blocks the loopback address from trying to talk to us. So that's what is going on there. So we have done all of that great stuff. And we'll apply changes and whatnot. That's about as much fun as there is to be had on the Interfaces tab. For our next little experiment, the only other things we can do is there is actually like kind of an interface grouping thing inside of pfSense that's kind of like zones, but it's not as cool. So next thing we do, if we go to Firewall and Rules, there's lots of fun stuff we can do in here. This is where we're going to spend a good chunk of our time. Actually, we're going to continue a quick pfSense tour. So right here, I'm going to use reverse psychology now. When you're going through doing stuff in pfSense and you're having trouble, don't ever go look at the logs. Don't ever go do that, because the logs inside of something are never going to help you figure out what's wrong, right? Yeah. So if you go to status and system logs, it has logs for all sorts of stuff inside of it. It's pretty cool. Like this is just all system stuff. But if you're configuring firewall rules and you're like, oh, I don't know what's going on, if you go over to Firewall, pfSense is going to sit there and actually say, like, here's all the traffic that I'm blocking. So if you can't get your packets to flow, go here and you might find interesting stuff. But don't ever do that, because that would help you troubleshoot. So we don't want any of that going on. Same with when we start to eventually go do VPN stuff. Like when we're playing with OpenVPN and the times are wrong on something, like your clock is incorrect, it'll actually even say in there, like, timestamps are invalid or something like that. It'll say, like, pretty obvious messages about stuff. So anyway, that's the extent of my tour for now, is never go look at the logs, because they're never going to help you figure out what's wrong. The other thing when we come in here that pfSense has for us is it allows the LAN network to go out to anything. So that's two rules that are in here made by default. There's a third rule right here. So if we look at the protocol is anything, the source is anything, port is anything, the destination is LAN address. So what is the LAN address as far as pfSense is concerned?
64 address or whatever we put in.
Yep, it's this address right up here, 64.43.242.1. That is the LAN address. That's the pfSense shortcut for basically saying the IP address configured on my LAN interface. The destination port is 80. You notice we cannot check the box and hit delete on this rule. What is this rule allowing?
You configure it.
Yeah, this rule is here allowing us to access this particular interface. So it was a fun experiment. If we went back to like pfSense of 2 years ago, folks would be in there configuring their firewall for this class and say, this wasn't a thing. You just had to have that rule in there, or you just were supposed to know. And I would usually warn, like, don't delete this, because it would go make the rule manually. And you delete the rule, and guess what would happen?
Get locked out.
Yeah, remember how I said, like, the one way you can do your firewall rules from command line is going in and using VI and editing an XML file by hand? You would get to do that to try to get back into your firewall, because you would have you'd have locked yourself out. So, luckily, I'm guessing there had been some feedback to pfSense about that, because you can no longer delete that rule, which is pretty nifty. Just for the sake of us going through and doing stuff, I'm going to actually delete the other LAN rules inside of there. There we go. We hit apply changes. There we go. Life is good. So if we do a tour, we get our LAN, our WAN, and the DMZ interfaces are all inside of there. Yeah.
My DMZ is not showing.
Okay. If your DMZ interface isn't showing up in this list, probably what you're missing. If you go back to interfaces and then DMZ,
Yeah.
and I'll click that, there's probably an enabled checkbox up at the top. Yeah.
My bad.
This is probably what you're missing.
I know.
Okay. So there is, I just went and deleted all of the rules on my LAN interface. There are servers running that are connected onto the DMZ right now, so we're going to play with those, which I'm pretty confident are running a web server. So we're going to make a rule from scratch. It's gonna be a big day. Make a firewall rule. So add, and we have all sorts of fun stuff we can talk about inside of here. So we have pass, block, and reject. Pass is pretty obvious. Let the packet pass through. Block is going to do what?
Drop.
Just drop it. And reject is going to do what? Yeah, it's going to send a TCP reset or whatever equivalent to that. So since we're letting traffic through, we're going to pass it. The next checkbox is you can create a rule that is inactive right on the fly. If you're doing stuff like that. So that will disable the rule. Nothing to worry about there. The next one is the interface that this rule applies to. So if we're making a rule that's letting our admin machine connect over to the DMZ machines, what interface is this going to apply to? Is it going to apply to LAN or DMZ? So, the rule that we use when deciding which interface to apply stuff on is who is going to see the packet first. So whichever interface sees the packet first is going to be the interface that has the rules for it. So this computer that we have that's running on the LAN connected to the LAN interface is going to the DMZ. So when this computer tries to go to the DMZ, which of these interfaces will see it first? The LAN will, yeah. Because the LAN in this case is the default gateway and all that good stuff. It's in charge of taking the packet and sending it over. If we were allowing someone from the internet to connect to a server in our DMZ, which interface would it apply to? It would apply to the WAN, because the WAN interface is going to see the packet first. The only time we would make rules in the DMZ is if we were saying we want to allow a server in the DMZ to talk to server in the LAN. So then the DMZ interface will see it first. So LAN is what we're going to pick there. Address families, we're going to go for IP4. And if we're going to allow web traffic, what protocol do we want to use? TCP.
I guess we could use both.
Well, for a web server, it'll just be TCP. If you were wondering in the world of firewalling, if there's anything other than TCP and UDP, if you click the list, there are many things, actually. So, what is our source going to be? And there's multiple right answers for this.
LAN network.
So we could pick LAN net. So what will pfSense assume if we pick LAN net?
Like any IP address coming from that network.
Yeah. What it's basically going to do then is take the source IP address that this would apply to would be 64.43.242.0/24. That's what it's going to assume if we pick LAN net.
But it also assume anything coming in
No, it doesn't actually. If we did any, then this rule would apply to any packet that gets to the LAN interface then. So this is where we come down to like, what is the right way to do this? If we think conceptually, are we going to have any IP addresses other than the LAN subnet ever talking on the LAN network's interface?
Should.
Probably not, no. Yeah, we should. There'd be something weird going on if there was. Like someone has somehow configured a router inside of the LAN or something weird like that. So any is probably safe. If we want to make our rules basically like as tight as possible, we would use LAN net. There's also the invert match button, and there's a time and a place for that. But generally speaking, my like rough rule is if you're using that, you're making your rules wrong. But there are actual instances for it. What is it not asking us for when we're specifying source information?
Forward.
Yeah, if you actually hit display advanced, that will actually show where you can specify the ports. But is there anything for us to specify? No. There's going to be something you're doing, like there's weird networking going on if you know the source port. Not saying it doesn't ever happen. It's just kind of weird. So our destination. Let's do, I want us to be able to browse the website on MSP server 1, which is 64.33.152.100. So, whoops. Here we are. Scooch this over. So we can do single host or alias. And who's going to check and make sure I enter the right IP address? 64.43.152.100. So our destination address is 64.43.152.100. All right. Are there other ways we could actually do this? We could do something weird and enter that with /32. Is there a difference between them? Between the two? No. When we do the single host, that's actually what pfSense is doing in the background. This is giving us the tour of like how different firewalls work. Most firewalls, this is actually what you have to configure. You don't get to say single host or network. You just say the destination IP address is that /32. When we subnet out the /32, how many addresses does that come to? Yeah. So either one, I'll just go back to single host. It doesn't really matter. Destination port range.
What does the DMZ address option do
The DMZ address?
then? It doesn't appear to allow you to actually pick an address.
No. So when you pick DMZ address, that would be something that I don't know why you would ever do. But that would allow anyone on the LAN to like be able to ping the DMZ interface.
Just the firewall.
Just the firewall interface, yeah. The reverse side is, let's say we had, I don't know, let's say we wanted to let computers in the DMZ access the admin interface. Then in the DMZ we would say allow them to go to the LAN interface. Again, not something I'd probably ever do. But yeah, that's why that's in there. There's also like WAN address as well. Same thing going on. For every interface you add in here, you'll see WAN address, LAN address, opt1 address, opt2 address, stuff like that. And that's all the address that's specifically configured on there. Oh no. 64.43.152? 100? Okay. So our next option is, what is the destination port range? So what port are we going to need for a web server? 80. So we can enter in the range, a custom range of 80 to 80, or we can go into the drop down which maybe it's not going to let me. Oh, there we go. And pick HTTP. Doesn't really matter. If you enter the ports manually, it's going to go do the drop-down thing for you as soon as you hit save. Just a nifty little perk of pfSense, I guess. Going forward, here's another tricky one. If you're troubleshooting stuff, by default on this pass rule, when it allows a packet through, it's not going to log anything unless you check the box that says, when this rule becomes true, make an entry in the event log. And then lastly, put a description in there. So here's my stance on descriptions. Because there are some folks that will say like, well, my firewall rules are self-documenting. I assume if you ever have your teachers in a programming class say, you need to enter comments in here, you're like, well, my code is pretty self-explanatory. Obviously not if the person grading it's like, what the hell are you doing? So same thing goes here. If you're having troubles with your firewall rules and you're submitting like a screenshot, you're sending me a screenshot in an email being like, do you see something goofy going on here? Please, please, please put descriptions in there so that I know what you're at least trying to do with this rule. So in here we would say like, allow the LAN to access server 1's website. So that's a pretty generic explanation of like, oh, you're trying to get the computer on the LAN to be able to go over to the DMZ to get to the website. Got it. So we're not going to go into advanced settings for today. We will do that later on as well. There are many advanced things that we can play with. So when we come over here, hit save and apply. And remember back when I was saying like there's some pretty generic firewall syntax? So that's what we've got. We've got, it put the protocol first, but source IP address is the LAN network, the source port is any, the destination address, destination port, all that good stuff. So in theory, we should be able to go to 64.43.152.100. Aha! And we get an exciting web interface full of multimedia and whatnot, right? So, the other thing is, what's the spot you should never go look at? Because it contains evil?
Logs.
Status and system logs. So when you're never visiting that, when you come over here, you should see, I forget, did I check the log thing or didn't I? Oh yeah, here we go. Right there. We see, hey, we let the traffic through. We see the source, we see the destination port, we see the source port, and we actually see the protocol inside of there. And we see the good old green checkbox because we allowed it. Lots of stuff getting denied here. What's going on here? When we look at this deny traffic, the LAN is the interface that saw it. What's the source IP? Who is that IP address? That's us, yeah. That's like the computer we're on right now.
Yes.
And we see it's going to 64.43.242.1. Who's that? Yeah, it's the gateway. That's the LAN interface on the firewall, and it's trying to go to UDP 53. So what is Windows trying to do right now? Or something inside of Windows. It's trying to do what kind of connection? UDP 53, what is it? I think we need to have a port math quiz. DNS plus web. What is it going to be? 53 plus 80, right? Those are stupid, silly quizzes to give. So DNS UDP 53, that's what's going on. So something's trying to make a DNS request. I don't particularly know what it is, but it's probably the little, oh, the icon's not there. It's probably the Windows like checking if I have internet access thing going on. So it's trying to go out to a website, but it needs to do a DNS lookup. Or it could be Firefox looking for updates or stuff like that. It's actually really hard if you're using Windows to like be quiet on a network, because Windows is just always talking. So, anywho, that is where we are going to stop for today. I am going to be in California next week, so we will not have class. I am going to post an assignment and video and good stuff like that for when I'm gone. I'll shoot out a message once that's up. So that is my promise. I'll never leave you with nothing to do.
Thank you.
So, yeah, because I know you all are super worried about that, right? So eventually we're going to have an assignment that's using MSP in Chicago and basically twice as many virtual machines and network interfaces and stuff like that. But what I'm actually going to do is just kind of do like a little mini lab involving these things to get all of our feet wet. So anywho, I will see everyone in a week.